Okay, as said, I'm from Zurich University of Applied Science, Institute of Embedded Systems, and we do research there with many industrial partners. We're funded through this research, and we, on the other side, teach. So we have things floating from industry to education, as well as from research education out to industry. Now, Michael Richardson gave a very nice speech, an introduction on Anima. I'm going a bit from another angle, from the building automation system, and will introduce you to a project that we did together with Siemens Building Technologies. So we did a proof of concept in the last 2 years on where we were prototyping what the Fair Hair Alliance is proposing to authenticate devices in building automation systems. Now, we do have a paper out, so there will be, if you are interested in the details there, under this link, you can read a lot of details, and I will be very happy to also discuss things there if you find points in there to discuss. Okay, let's see. Okay, so let's go through the environment. So in the last couple of years, we've been getting IPv6 all down to the field level. So we're building wireless field nodes here, the leaf node in buildings that can do an IPv6 access from the internet if you want. So that can be from a closed or on-site or off-site, but it's IP accessible node there. And we are using here the thread protocol stack. So you see it on the left side here with the, or the right side, sorry, with the 802.15.4 MAC, the 6LoWPAN IPv6, UDP, and then the DTLS and the CoAP RESTful interface on top of that. And in this environment, in the sensor network, we do have routers, the edgy devices here that are always on, and we do have low power leaf nodes. That is the part that we build and prototype at the Institute of Embedded Systems. So I'm going to talk here quite a lot about the leaf node, and we now, as we have a coalescence between the IT environment on the top and the OT environment, going out to the light switch, going out to the smoke detector, or whatever device you're building out there. So with this coalescence, authentication becomes a big issue for those individual leaf nodes. I need to know with which device that I'm actually talking, and I don't only need to know who's the manufacturer, but I also need to know which operational identity that device has. And I'm going to talk about this process here, this autonomic, secure bootstrapping process that is based on the risky Anima things that Michael explained earlier today, and is now integrated into the Fair Hair proposal that is being discussed. Okay, so basically the challenge when we have such building automation devices is we do have a manufacturer somewhere, and we then have a very long supply chain where these devices run through. Anything can happen to those devices on this long supply chain. And of course, the manufacturer does not want to customize those devices for an individual customer. He wants to drop ship the things, so have all the same devices shipped with an identical firmware load. And the devices are exposed while they go through the whole logistic chain through a lot of a lot of potential manipulations, and at some place an IT integrator has to take the device and probably at the moment manually enroll that into that building environment. And that IT integrator then is questioned, does he trust this device? Has it been manipulated? Who has owned it previously? So this is a manual IT provisioning process that you have at the moment. And now you're going, as the number of devices is incrementing quite fast, and so you need a way to automate this enrollment process, and you want to replace that IT integrator with a fully automated service. So taking the IT integrator to what we call here a registrar, similar to what we heard before on the Anima side. And the registrar represents the entity that decides who can join this building domain, that acts as a registration authority and takes the decision and is responsible for who comes onto this domain and who is not allowed to be part of that domain. And the goal is to have a fully automated enrollment process there. Now let's look at where we start from before we start the process. So there are two important trust relationships at the beginning that are behind this idea. We do have what I call here the leaf node, that is the device that I want to, the low power end device that I want to enroll in the end, the pledge in some standards. And on the other side, we have the registrar, the automated IT integrator. And then we have a trust relation that the leaf node is trusting, of course, the manufacturer. Why is it trusting the manufacturer? Because a manufacturer identity has been put onto the device during manufacturing, and that initial device identifier basically contains two things. So it's the manufacturer device certificate, so an individual certificate for the device with which the device can has a certification that it is manufactured by this specific manufacturer. And there's in addition the manufacturer's CA public key that is unmutable, stored within the device, that allows the device to verify that it is indeed talking to the manufacturer. And then there's a second trust relationship, the trust between the registrar and the manufacturer, or the manufacturer authorized signing authority. That is the case because the manufacturer has bought the building operator has chosen to buy devices from that manufacturer. Therefore, you can assume that he does trust this manufacturer, and then this can be configured manually, probably by an IT administrator. But what we don't have at the moment is we do not have trust yet between those two. So the leaf node does not have any trust relation with the registrar, and nor does the registrar trust the leaf node. And so this automatic secure bootstrapping basically is what Anima proposes to build up this trust and then to enroll the devices into the network. So it's basically a three-step process. We first establish a mutual trust between leaf node and registrar on the basis of what IETF, Anima, Brisky proposes. Then do an enrollment over the secure transport. Once you have the trust in place, you can do an enrollment. And with that enrollment, will get a device certificate for the building domain. And with that device certificate, you can, in the third step, then do an operational enrollment. You can really start communicating within the application, within the building environment. Okay, so the first step is establishing the mutual trust between the leaf node and the registrar. And this is a voucher-based system based on X509 certificates and on digital signatures. And when the leaf node is installed, it will build up a connection to a potential registrar. It will ask for a voucher request that the registrar takes, encapsulates it, and forwards to the manufacturer authorized signing authority. And the MASA here will perform certain checks, depending very much on the application that we are in, and then it will provide in return, if it is happy with these checks, then it will provide a voucher, and in the end, the registrar, on behalf of the building operator, can take the decision whether it wants to enroll this device or whether it does not want to enroll the device, and depending on that, it forwards the voucher or not. So in the end, it's not the manufacturer that takes the decision. The decision is with the registrar, and the manufacturer just provides provides information to support such a decision. Okay, so how does this work? First of all, the leaf node, once it's powered on from a clean state, it will find a potential registrar. There are many ways how this could be done, but basically it comes up with a candidate for a registrar, and it builds up a DTLS session with provisional trust. It says, I don't know who you are, but I will provisionally trust you, and let's start an engagement and see if we can build up a lasting engagement here. And then the leaf node, through this DTLS session, sends out a so-called voucher request. In this voucher request, it has a nonce to prove later on that the freshness. It has its serial number in there, and it has the device certificate of the registrar it's seeing. So this guy said, well, I am pretending that I'm this guy, so here the leaf node says, well, this is who he said he is. And then it's going to digitally sign this with its manufacturer manufacturer certified key, and sends this to the registrar. The registrar, operated by the building owner, then encapsulates this voucher request. So we have the voucher request in there, adds some more data, digitally signs it from its side, and sends it on to the manufacturer authorized signing authority. And now with these signatures, the MASA will check different things. Well, first of all, is it a genuine device that issued this? Is the voucher request, has it been received from the same registrar that the device itself is seeing, or have things been messed up there? And it can add a lot of other checks that it is doing there, which are very dependent on the application that you want to implement. But in the least, it will lock the device. So say, okay, I've seen who is registering this. I have a trust relation there, or I know at least who that is. And I lock that in a device history. So I'm entering the leaf node under this owner, under this registrar as an owner who wants to use this device. Okay, and then when these checks are satisfactory, what the manufacturer sends out is a voucher, a statement that from his sides the checks are fine. It will also add additional information, for example, the device history. Who has owned the device previously? Has somebody else gone through this registration procedure before? And it sends this out to the registrar, and the registrar takes the decision. Now the registrar is the building operator. It's not the manufacturer who takes the decision, but it's the operator of the building that for liability reasons now has to take the decision, do I trust or don't I trust? And then this comes back to the leaf node, and the leaf node verifies the freshness of this voucher. It verifies the certificate here of it gets the domain certificate of the CA, of the building CA within the voucher, and therefore can now finally verify that it was indeed talking to the correct registrar or to an authorized registrar. Okay, and at the end of this process, we have between leaf node and registrar, they have mutually authenticated each other and now have mutual trust. And the mutual trust is then the base for the next step where the leaf node can go on and say, well, it generates a new private public key and it requests certification of this. So the leaf node asks for a certification of this key, of his key pair, and the registrar will then provide an operational device certificate. So we've gone now from the initial identity from the manufacturer to an identity, so-called locally significant secure device identifier that is significant for the building domain right here. So now the leaf node has a certificate that certifies that is allowed to operate within this building environment. And with this certificate, in the next step, in the third step, it goes out and enrolls and in whichever service it wants to or is allowed to. So based on this authentication, the node can be authorized here, for example, to push certain data over a mesh network through a border router out to an automation station, for example, and talk with that station. Now, coming to the implementation, this is what we've built here. We've actually implemented that in hardware using a Nordic SoC chip, 2.4 gigahertz system that can do Bluetooth and 802.15.4 communication. And we've included quite a few sensors on there that we can use to demonstrate this system. But more specifically, we've integrated with it 4 secure elements because we wanted to try them. We wanted to work with as many secure elements as possible. We've chosen 4 of them. And we have here of this node a small one with 1 secure element on it. And we have this small breakout board comes from a larger board. And on that larger board, we have 3 more secure elements. And we've used this to prototype using an open thread stack that is openly available. And we've run that with Mbed TLS, open source TLS system that we connected to the registrar. And we can then use these 4 secure elements to put parts or the whole DTLS session into these secure elements. Depending, the secure elements have slightly different feature sets, so not all of them can do quite the same thing. So we used 4 vendors here. We've done extensive measurements on execution times there, on power consumption, on peak currents, on dynamic measurements there, and we have those data available. We are trying to publish these things. We have the paper print ready almost, but we're still fighting. One of the four is still holding back his agreement on behalf of NDA parts, and we're not allowed at the moment to publish that, right? So, but going through this process, we've seen, working with these 4 secure elements, it's been quite a hard work, not so much, if you want, technically, but for each of those secure elements, you need an NDA almost signed by God, slightly below that, and then you need to work with the field application engineers. It goes back and forth quite a few times, and it's been a lot of work to get it up and running, and it is very difficult for a company, at least I perceive that, if you are starting security, you want to put a secure element on your device, and which one do I take? Where do I start? What do I need? You have to hire 2 or 3 people and really go into that, into those details, and I clearly see there that you need some harmonization there. It has to get easier to place secure elements or on-chip security in products like this. Otherwise, we will not be ending up with secure systems. Now, okay, here we're testing this in different environments. We have one test system where we're using the leaf node with an open thread border router here, connecting to a registrar on a Raspberry Pi, having Masa on a Raspberry Pi. This is a small test setup. We are running larger test setups as well, together with Siemens, who are building registrar and Masa implementations, and we are testing against those implementations and have this mode up and running there. So, to conclude, we have a fully automated enrollment process for IoT devices. The way Fairhair is currently specifying this, based on Anima Brisky. We are starting from an initial device identifier, and we're transferring this to a local device identifier which is given by the building operator, so you're not dependent on the manufacturer, so you are only dependent on the manufacturer in the moment where you bootstrap your device. And the thing is based on public key cryptography, and we have a fully functional implementation based on software, embed TLS, but we also have the hardware support with 4 different secure elements. And I have the details out. We had a demo at Electronica a few weeks ago, and we have the paper out which describes everything under that link. And I'm very happy to take any comments, improvements, discussions on these algorithms, on the way this is done. Yeah.
Okay, Andreas, thank you very much indeed.
Thank you.